Hello friends, welcome to Electronic Circuit Hub. So today we are going to understand about the simulation of precision voltage limiter or clipper circuit by using the multiple stages of operational amplifier. Okay, so we will understand the shunt clamping occurs for input signals above 3.3 volt or below 0 volt. Okay, let's say you are getting some sinusoidal signal. The amplitude of your sinusoidal signal is, let's say, 5 volt peak or 10 volt peak to peak, and at the output stage you want the signal which is which lies between 0 volt to 3.3 volt. So if you look at my input side, this is my input side, and my amplitude is 5 volt. I am using simple 10 hertz frequency. So 5 volt amplitude means 10 volt peak to peak signal. Then R1 is the limiting resistor, let's say 2 kilo ohm, and then you can use the higher value resistance as well. That's not an issue. You can use, let's say, uh, 4.7 kilo ohm. Let's see what is going to happen if you use 4.7 kilo ohm. Then we have the first stage of our operational amplifier. In the first stage, if you look at here, I have connected the input signal to the inverting terminal, and non-inverting terminal I have connected one voltage source, and the amplitude is DC 3.3 volt, right? Output of your U1 first stage of your operational amplifier, I have connected this diode in the reverse fashion. The cathode is connected to out pin of your U1. This stage basically clip or limit the voltage signal which is above to this reference signal of 3.3 volt. So in the first stage, what I am doing here is I am clipping the input signal greater than 3.3 volt, and in the next stage, in the second stage, what I am doing here is I am clipping the signal which is lower than 0 volt or which is below 0 volt. Okay, and then the output of this second stage is connected another operational amplifier, one more stage of operational amplifier, and this time this operational amplifier works as a buffer. That let me run the simulation and let me show you the different voltage waveforms one by one and how it looks like. Okay, so this is your first stage signal, this is your first stage voltage, and if you look at the first stage, the amplitude is plus 5 volt, and this side the amplitude is minus 5 volt. Okay, and so if I cut my first stage here, let me cut my first stage and run the simulation. So if I cut my first stage, what output is going you are going to get? Okay, so if I cut my first stage, you can see here, you can see this waveform, which clearly you can see, guys, at the top side you see my the input voltage is clipped, and it is clipped to 3.3 volt. The maximum amplitude for the positive side is 3.3 volt, but at the bottom side, negative side, you see the amplitude is 5 volt. Okay, since I'm using here the dual supply, that means I'm using 5 volt per positive supply and minus 5 volt for negative supply. That means I'm getting the positive voltage of 3.3 volt because of the first stage is clipping the voltage signal above 3.3 volt, and in the and it is passing the signal below 0 volt in the first stage. Now what you do here is, let's connect our second stage and let's see the output of the second stage. And once I connect the second stage, and let me run the simulation for first the second stage, and once you run the simulation the second stage, and what signal you can see here is, you can see now both positive and the negative signal, and a positive signal with the amplitude of 3.3 volt. So you see with positive signal the amplitude of 3.3 volt, and the negative signal amplitude you see here is 0 volt. That means your first stage is clipping the signal above 3.3 volt, and your second stage, the second stage U2, is clipping the signal below 0 volt. And what about the third stage? Let's have a look on the third stage. So in the third stage, since this is the buffer stage, if I click this, you are getting more or less the same signal of the second stage. There is no change. The V out and V buffered, if you look at, they are overlapping each other. That means in the third stage the signal is same, only there is a isolation in the buffered signal.